Welcome to The Explainer. Today, we are diving into a really cool development in AI image creation. It's a new approach that might, just might, finally solve this frustrating tug-of-war between getting an image fast and getting an image that's actually good.
Okay, so let's get right into it. For a while now, if you're a developer, you've been stuck with a pretty tough choice. On one side, you've got diffusion models, like Stable Diffusion. They make these absolutely stunning, photorealistic images. The problem? They are slow, and they take a ton of computing power. Then on the other side, you've got autoregressive models. These things are lightning fast, but the quality often just isn't there. You get weird artifacts, errors, a lack of detail. So you have to choose. Do you want beauty or do you want speed?
Well, a team of researchers from MIT and NVIDIA saw this exact problem and asked a really simple but kind of profound question. Why not both? What if we didn't have to choose? And their answer could seriously change how we all think about building generative AI.
So, let's introduce our hybrid hero. It's a new approach they've developed called HART, which stands for Hybrid Autoregressive Transformer. And really, the name says it all. It's a hybrid model, designed to fuse the raw speed of those autoregressive models with the incredible eye for detail you get from diffusion models.
Now, the way they explain it is just perfect. They use this analogy of painting a masterpiece. Think about it, right? An artist doesn't start in one corner and paint pixel by perfect pixel. No, they start with broad strokes, sketching out the main shapes, the overall vibe. And then they go back in with the smaller brushes to add all the fine, intricate details. That's the whole idea behind HART.
And here's how that two-step process actually plays out. First, you have the fast autoregressive model doing all the heavy lifting. It just blasts out a quick and dirty draft of the image. It gets the main structure down, the basic colors. Think of it like the artist's initial sketch.
Then, in step 2, a much smaller, way more efficient diffusion model comes in to add the finishing touches. And it does this using a clever trick called residual tokens. Now, these tokens are specifically designed to hunt down and fix all the little details that the first, faster model might have missed. We're talking about sharp edges, the texture of a fabric, or the tiny details in someone's eyes.
And that right there, that's the secret sauce. The diffusion model isn't starting from scratch with a blank canvas. It's just coming in to clean up and refine an already solid foundation. This makes its job way, way easier, and it's the real key to why HART is so incredibly efficient.
Okay, so the idea sounds elegant, it sounds smart, but does it actually work? Well, let's get into the results, because the numbers are pretty striking and they tell a really clear story. Let's talk about speed first. Compared to the big, state-of-the-art diffusion models, HART generates images of the same quality about 9 times faster. Let that sink in. Not 9%, 9 times faster. That's a huge deal for any application that needs images right now.
And it's not just about speed, it's also about efficiency. HART uses about 31% less computational power to get the job done. And you know what that means? It means this kind of tech could potentially run right on your laptop or even your phone, without having to ping some expensive GPU in the cloud.
But this might be the most impressive part of all. A HART's model with just over 700 million parameters can create images that are actually higher quality than a pure diffusion model that has 2 billion parameters. So it's smaller, it's faster, and it produces better results. It's kind of the whole package.
So the numbers look fantastic. But let's bring this down to earth. What does this actually mean for you? For the developers and engineers out there who are building things with AI today?
This is the big question, right? Should you drop everything and change your entire image generation pipeline? Well, like pretty much everything in tech, the answer is it's complicated. So let's look at the pros first.
For anyone building something where speed is absolutely critical. Think about real-time design tools or dynamic assets for a video game. This hybrid approach could be a total game changer. It also just proves that there are other ways to get top-tier images without just building bigger and bigger diffusion models.
But, and this is a big but, we have to do a little reality check here. This is still a research paper. It's not a tool you can just go download and use today. The code isn't even public yet. And maybe the biggest hurdle is that a new architecture like this means we'd have to rebuild that whole amazing ecosystem of tools, like LoRa's and control nets, that makes models like Stable Diffusion so powerful and flexible.
So the takeaway here is you're probably not going to switch your production pipelines tomorrow, but you absolutely should be watching this new architectural pattern very, very closely because its potential goes way beyond just still images.
And that's really the big ambition here. The team behind Heart isn't just stopping with pictures. They're already looking at how to apply this exact same hybrid idea to generate video and even audio. Just imagine being able to create high-quality video as quickly as we make static images today. That is the kind of future this could unlock.
Which kind of leaves us with this final thought. Maybe the next giant leap in generative AI isn't going to come from one single massive model that tries to do everything perfectly. Maybe, just maybe, it's going to come from smart, efficient, clever combinations like Heart that prove that sometimes the best way forward is to take the best parts of two great ideas and bring them together.